So, welcome everybody. Today I want to talk about 4 architecture concepts that are important for basically every product you build. They are ordered in in a way of importance. Like we begin with the most important thing and think you do it at the beginning and go down the path, so to speak, of the software to a more advanced topic that you might need or might not need, but is still valuable to think about in whatever you do. So in the beginning, when you start building your software, building your project, building your product, you think about how do I structure it roughly, what I want to achieve. Let's say you build something completely new, utter greenfield approach, let's call it new startup, whatever. So there's nothing. Then your first thing and the most important thing is to iterate fast and to learn. How is the basic architecture looking in such an environment? I assume if you completely start from scratch, you don't have much developers, maybe you're on your own, and the obvious high-level architecture there is a monolith. Don't make your life super hard in the beginning by going microservices from the get-go. It's just not worth it. And I say this with 12 years in distributed computing. Always remember the first law of distributed computing. Don't distribute your computing. Stuff can just go wrong. It makes it complicated. Microservices are there to address certain issues. They are the default way of scaling up from a certain perspective. They are there to address dependencies on central pieces of code with multiple teams. So they don't step on each other's toes basically when they try to change something. So there's a reason why microservices exist and are the default for larger solutions. But in the beginning, you don't build a large solution, you build something that works. And you try to figure out what exactly that is and how it will work and who needs it and how user will actually interact with it. And you don't even know what parts of your system needs to scale. So just focus on a monolith and break it up later. It is way easier and the best approach. However, if you're already in a large organization and there's a lot of software around already and you just build yet another system next to all of them, you're not in the complete beginning of a new software or a new product lifecycle. There's already a lot of stuff there. So you really need to think, is monolith still the best approach there? Because I have to integrate in multiple systems. Maybe I can reuse some existing components. So there the cards get reshuffled quite fast. Yeah, maybe the underlying support structure is already there for microservice architecture. So you get a lot of things for free, like monitoring and tracing and all of that, and a lot of coding guidelines. And then the decision might very well be more and more in favor of microservices from the beginning, because you're not at the complete beginning. You are already way advanced if you look at the broader picture. Same as if you reinvent or re-architect an existing system, you're not at the complete beginning. You already know what the customer needs, you already know how it interacts, you probably know why system version 1 sucked, and just look at those things, make them better. Again, to the point, if you're in the beginning, it's all about learning, experimentation, finding out some truths about the thing you want to build, and then go from there, iterate from there, and make it better. And this does not only apply to the overall structure or architecture of your system you want to build, but obviously also to the programming language. If you don't have no idea what it actually is that you need to build in the end, but still are in an experimentation phase, the higher level of language you can use is the better. Like the whole lean startup movement does this pretty well, I think. And they say, well, to figure out what the customer need, you don't even need running software for that. So use the right software for the right problem you want to solve, try to use as high level of abstraction software you can, like Ruby on Rails or JavaScript or stuff like that, to make progress the fastest way possible, to learn more about what it is what you're building, how does it actually work, what does the customer actually need. Try to validate as fast as you can. Step 2 is, let's assume you have found out what the customer actually wants. You build some things. You see, okay, those interactions work. We need maybe a database here for caching reasons or whatever. This part is tricky. And you figured out what to build, how it probably works, who to talk to often to get good feedback, stuff like that. So you did your initial homework and you built some code already. Now it's time to actually think about the architecture. This pays dividend to then think about, okay, how maybe we should structure things in a clever way so we can move forward from there. We solve those issues when they arise. So we actually solve architecture decisions quite late when we already have working things in place. Why? Well, because we don't know from the beginning what and how we want to build something. We don't know if it works, and we don't know what it actually is that we want to build. So the whole idea of we could build it right the first time, well, it doesn't work. It never works. You don't have the same people from beginning to end. You don't have the same target picture. You just don't know. This doesn't work. This is the whole idea about agile. You move on, you learn, you gather some information, you gather some truths, and then you can build with those, with things you actually validated for yourself, and you learn and you know, okay, those are things we know are correct. We put those in place, and then we can start to figure out how we move those building blocks around and structure it. We solve architecture decisions when we actually need them and not beforehand. Actually build something first and figure out what is actually needed and how it works, and then we look at the architecture. I've already made a video about that. Know what to build, then you can start building it correctly. A good general tip there is to push for code modularity, like shared services libraries, just to make it easier to split apart the code later, but also to enable more developers to work on this code base together without standing in the feature of each other. Good developers usually push for this kind of approach themselves. So number 3 is, let's assume your product grows. You made some releases for the early customers. They integrate, they looked at it, they gave you feedback, they can actually use it at the moment, and you still deploy features, whatever they need. Maybe some broke already and you had to do some bug fixing, but you still have a small code base, small enough so you can do that quite easily. But still, it starts to clog you down. Once you are in production, things get complicated. This is just the way it is. Latest at this stage, it's a good idea to invest in deployment of your software. Like, get the whole complexity there solved centrally, so your developers can focus on building the features, on improving the code, on their domain, basically, and make the deployment of new features as easy as possible and as pain-free as possible. So this is a classical CD, continuous deployment to continuous integration pipeline. Investment in those pays huge dividends. I mean, you can integrate all your tests there, automated test cases from regression tests, end-to-end tests, and you can move way easier into smaller and smaller and smaller deployments. So your developers don't need to bundle and manage complexity in big releases and do troubleshooting with big deployments and figure out why did something break now. It's way easier if you have smaller deployments to figure out, oh, okay, this one deployment had an issue here and there, then just fix forward. Also, this fix forward is way faster if everything is automated and of high quality and super robust. So yeah, there's a reason why the CI/CD concept is like there for over 10 years now, because it's that good. It's the default. It's the industry standard, and it pays dividends to invest in a good CI/CD pipeline. Just a good overall goal to have at this point of your journey, or even earlier. Never hurts to have a good CI/CD pipeline, especially with the out of the box ones you can get already. I mean, Git has already most of the tools you need. There's no reason not to have a good pipeline for your product. So, and the last thing I want to mention it because I'm just a big fan of it, because I like it. The concept is cool. Maybe you don't even need it for your product, but let's say everything works really good, and now you want to like level up your product and in being even more centric for the user, and you want to do experiments. You want to figure out, well, what UI actually performs better. You want to do an A/B test, so to speak, for your customers. Or you say, okay, we have so many customers now, new features we want to roll out in phases or in waves. All those things, they can be tricky, or if you have the right tools in place, they are more easy. And what I want to highlight here is the idea of the feature toggle. Basically, you hide code, hide functionality between toggles, switches, which you can then enable or disable for certain users, for certain user groups. This enables you to release things on demand and not when they are basically done in development and get pushed to production, and then everybody has this new feature. No, product management can decide, okay, I want this feature maybe tomorrow, a week from now, at Black Friday, whatever. So they can just toggle a feature, and it's live. This is a very cool idea, cool concept. I really like it. Worth implementing for more mature systems, more mature products. So, and since this is most complicated concept, I have this link from Martin Fowler's website, who goes into good detail level and gives a good overview in what kinds there are, and also what you need to think about. And for me, it was a good overview, so I encourage you, if you're interested, check this link out. I think it will help you. And with that, thanks very much, and see you next time. Bye.